Alright everybody, for this video we're going to be looking at this concept of float time in a network diagram. Now float is a very fancy word for describing the amount of time you have slack in a task. And what that means is how much time could you delay that task without it holding up the entire project, right? So we've already identified that the critical path is C, G, H, I, and J. We must do those tasks in that order without any delay, because if we delay any of those tasks, we will end up taking longer than 23 minutes to cook this spag bowl. So by definition, tasks on the critical path have no float time. But you can look at other tasks, and they should have some element of float. And so you could basically say, for task D, for example, D is grating the cheese. Now, grating the cheese takes 1 minute. You can start it straight away, but you only have to have it ready for the final preparation of the spag bowl, right? You can have not done it for 15 minutes while you're simmering the sauce and cooking the pasta, just so long as with 1 minute left before the end of the task, you basically say, or before task J, you say, okay, take 1 minute, grate some Parmesan cheese, sprinkle it onto the dish so that the dish is ready to go. And that's what basically float means. It means that you've got spare time where you don't have to start it immediately. And how much slack do you have on that task before you have to start it? And so I'll explain how it is that you'll actually calculate that. So if you look on a revision website or in a textbook, you see this formula for float, where they say float is equal to the latest finish time minus the duration minus the earliest start time for that task. Which seems a bit sort of daunting, and when I first was learning about this, it sort of confused me a bit. But once you work through it, it gets a bit easier, and it becomes a bit easier to understand. So let's just do a couple of examples here. What is the float on task D? Well, what we have to do, if you want to do it by the book, you actually say, so you say, well, task D, where is the latest finish time for task D? The thing is, each of these nodes has a latest finish time on it. Remember, that latest finish time is for any task which precedes that node. So if we're looking for the latest finish time for task D, we find it here on node 7. The latest finish time for task D is 22. So 22 minutes. By minute 22, we have to have finished task D. It takes 1 minute to do task D. That's the duration. We just get that from the task there. So 22 minus 1. And when can we start task D? We can start task D using its earliest start time. Remember, in any node, the earliest start time is the earliest start time for any task which follows from that node. So the earliest start time for D, we look for here in node 1. So 22 minus 1 minus 0 means that we've got a float time of 21 minutes for task D. In other words, we can wait around for 21 minutes while everything else is happening, and then say suddenly, oh, hold on, we need to grate our cheese. But as long as we do it before 21 minutes, because it only takes a minute, we'll get it done by minute 22, give us a minute to plate everything together, and we'll be done by minute 23 without delaying the project. We can do this for any other task along here. Let's say task E, for example. So the float on task E, well, we look at the latest finish time. The latest finish time for task E is here on node 4, 21. So 21 minus the duration, 10 minutes, minus the earliest start time, which is 2. We can start cooking the pasta after we boil our water after 2 minutes. So 21 minus 10 is 11, minus 2 equals 9. We can work that out like that. You can even work out floats for whole sets of tasks if you want to. You could do the float for tasks A, E, and F together. And to do that, you would just say, well, what's the latest finish time that we have to finish all of these tasks? Latest finish time for A, E, and F is at the end of F. which would be the 22, minus the duration of all of them together, 2 plus 10 plus 1, which is 13, minus the earliest start time for all the tasks coming before task A, which would be 0. So the float time for the entire arm is 22 minus 13, which again is 9. So this whole pasta cooking arm of our network diagram, we've actually got 9 minutes of slack width. So you can, it's probably best to get your pan and your veggies going before you start to worry about your pasta. Just so that we're clear, if you try to calculate the float time for any critical path activity, it will be 0, because by definition the critical path activity is the one that you cannot afford to delay without delaying the overall project. So if you look at, for example, the float on task H, if we did this float on task H, it's just a bit of an exercise really. Latest finish time is 12 minus 5, the duration, minus 7. 12 minus 5 minus 7 is 0. So another way of defining the critical path activities are those activities which have a float of 0. And that's it. That is all that you'll need to know with how to construct a critical path or a network diagram. Most likely, you'll only ever have to add in or annotate or change around an already drawn critical path or network diagram. I hope you found this useful. And in typical YouTube fashion, I'll say, if you found this useful, please like the channel and subscribe. You don't really have to. It's just a simple revision video. But yeah, let me know if it was useful. Good luck with your revision.